Hi everyone, I'm Whit Roy. Today I've invited an electrical tutor and an apprentice to have a conversation as they go through topics from the EWRB Electrician Theory exam. I hope you enjoy this style of learning.
Okay, Sarah, today we're starting topic 13 and we'll focus on excess current protection.
Yep, okay. I remember this is about fuses and breakers, right?
You're on the right track. Let's start simple. What does rated current mean?
Is it the current flowing in the circuit normally?
Close, but not quite. Rated current is the maximum continuous current a cable or device can safely carry.
Oh, right, so it's more like a limit.
Exactly. A safe limit without overheating.
So if current goes above that, it's a problem.
Yep. Once current exceeds the rated value, we call it excess current.
Excess current means more power, I think.
Not quite. Excess current mainly means more heat.
Ah, okay, heat in the cable.
That's right. Heat is the key issue here.
And heat damages insulation.
Exactly. Insulation can soften, melt, or even carbonize.
And once insulation is damaged, metal parts can become live.
Correct. And that leads to fire risk and electric shock risk.
So excess current protection is mainly about fire prevention.
Fire prevention and equipment protection, yes.
Not really about people then.
Good question. No. Excess current protection protects cables and equipment, not people directly.
That's what RCDs are for.
Exactly. We'll get to those later.
Okay.
Now, excess current can occur in two main ways. Do you remember them?
Overload and short circuit?
Yep, well done. Let's look at overload first. What is overload?
Is that when too many appliances are plugged in?
That's a good real-world example. Technically, overload is when current is slightly higher than normal for a long period.
So it's not sudden.
Correct. It builds up over time.
And short circuit is sudden.
Exactly. A short circuit causes current to rise very quickly to a very high value.
That's when active touches neutral or earth.
Correct. Both overloads and short circuits cause heat, but they behave differently.
So protection devices have to deal with both.
Right. Now, the exam often asks about close and cause protection.
I always mix those up.
That's common. Let's clear it up. Close protection is the more sensitive type.
Meaning it trips earlier.
Exactly. Close protection operates within 4 hours at 1.5 times the design current.
4 hours sounds long.
It does, but remember, this is for overload conditions, not short circuits.
Oh, okay.
Close protection limits long-term heating.
Which devices give close protection?
Modern devices like MCBs and HRC fuses.
So MCBs are close protection.
Yes. Now, cause protection is different.
That's the older type, right?
Generally, yes. Cause protection is less sensitive.
Does it trip slower?
Correct. It does not operate within 4 hours at 1.5 times current.
So it allows more heating.
Exactly. That's why it's considered less protective.
Which devices use coarse protection?
Mainly rewirable fuses.
Those old fuse wires.
Yep, and an important exam point, rewirable fuses are not permitted in new installations.
That's under AS/NZ 3000.
Correct. They may still exist in older installations, but not for new work.
So if the exam asks rewirable fuse equals coarse protection.
Exactly. Now let's look at common excess current devices.
Okay.
Rewirable fuses provide coarse protection.
Because the fuse wire melts slowly.
Right. HRC fuses provide close protection.
They can interrupt high fault currents safely.
Correct. MCBs provide both overload and short circuit protection.
Because they have two parts.
Exactly. A thermal part and a magnetic part.
Thermal for overload.
Yes.
Magnetic for short circuit.
Correct. Now, what about overload relays?
Are they used in motors?
Yes. Overload relays protect motors from long-term overload.
Do they protect against short circuits too?
They do not.
So they need a fuse or MCB as well.
Exactly. That's an important exam point.
Okay.
Now let's talk about coordination.
That's matching the device to the cable, right?
Yes, the protective device must protect the cable it supplies.
So the device rating can't be higher than the cable rating.
Correct. If it is, the cable could overheat before the device trips.
And if the device rating is too low, it trips too often.
Exactly. That's nuisance tripping.
So correct selection is important.
Very important. Now, one more examinable term, breaking capacity.
That's the maximum fault current the device can interrupt.
Correct.
So if the fault current is higher than the breaking capacity, the device can fail.
Yes, and that's a serious safety risk.
So breaking capacity must suit the prospective fault current.
Exactly.
Okay, that's a lot clearer now.
Good. Let's finish with a summary.
So excess current protection protects cables and equipment.
Correct.
It does not protect people.
Right.
Overload is long-term overcurrent.
Yes.
Short circuit is sudden high current.
Correct.
Close protection trips earlier.
Yes.
Coarse protection trips later.
Exactly.
Rewirable fuses are coarse protection and not allowed in new installs.
Perfect. That's a solid understanding of part 1.
Okay, Sarah, let's move on to part 2 of topic 13, and this is all about RCDs.
Yep, I know this part is really important for the exam.
It is. Let's start with the basics. What is the main purpose of an RCD?
It trips when there's too much current?
Not quite. That's overload protection. Try again.
Right, okay. It trips when there's earth leakage.
Yep, that's closer. An RCD provides supplementary protection by detecting leakage current.
Supplementary means it's not the main protection.
Exactly. It works alongside fuses and MCBs.
So fuses and MCBs protect cables.
Correct. And RCDs protect people.
Okay, that difference makes sense.
Now, how does an RCD actually detect a fault?
It measures current to earth?
Close. It compares current in the active and the neutral.
Oh, right, they should be the same.
Yes. Under normal conditions, current flowing out equals current flowing back.
And if they're not equal, something's leaking.
Exactly. That imbalance indicates leakage current.
Usually through a person or faulty insulation.
Correct. When that imbalance exceeds the rated value, the RCD trips.
And the rated values are usually 30 milliamps or 10 milliamps.
Yep. 30 milliamps is the most common.
10 milliamps is more sensitive.
Exactly. Now, why does the RCD need to trip quickly?
To stop people getting shocked for too long.
Right. It limits the duration of current through the body.
So it reduces injury.
Yes, it reduces the severity of electric shock.
It doesn't stop the shock completely though.
Correct. It reduces risk, not eliminates it.
Okay.
Now, let's look at Regulation 24. This comes up a lot.
That's about when an RCD is electrically unsafe, right?
Exactly. Let's focus on a 30 milliamp RCD first.
Okay.
At rated current, 30 milliamps, how quickly must it trip?
Is it 40 milliseconds?
That's at 5 times rated current.
Oh, right.
At rated current, it must trip within 300 milliseconds.
Okay, 300 milliseconds at 30 milliamps.
Good. Now, what about at 5 times rated current?
That would be 150 milliamps.
Correct. And the trip time?
40 milliseconds.
Exactly. Very fast disconnection.
And it must not trip too early either.
Yes. What's the lower limit?
It must not trip at 15 milliamps or below.
Correct. That prevents nuisance tripping.
So if it trips too slow or too fast, it's unsafe.
Exactly. If any of those limits aren't met, the RCD is electrically unsafe.
And it must be replaced.
Yes, not repaired.
Okay.
Now let's move to 10 milliamp RCDs. Why do we use them?
For extra safety,
Correct. Higher personal protection.
like in childcare centres or special locations.
Yes. Now, what is the maximum rated residual current for a 10 milliamp RCD?
10 milliamps.
Correct. And how fast must it trip at rated current?
40 milliseconds.
Yes. And at 5 times rated current?
Also 40 milliseconds.
Correct. Now, what about nuisance tripping limits?
It must not trip below 45% of rated current.
Exactly. That figure is examinable.
Okay, I'll remember that.
Now let's talk about RCD types. This is a common mistake area.
Type AC and Type A.
Yes. Which one is required in New Zealand for personal protection?
Type A.
Correct. And why?
Because modern equipment produces DC leakage.
Exactly. Pulsating DC.
And Type AC might not detect that.
Correct. Type AC RCDs may fail to trip under DC conditions.
So Type A is required.
Yes, that's the exam answer.
No need to explain more.
Exactly. Now let's look at RCD device formats.
There's RCCB and RCBO.
Correct. What does an RCCB do?
Residual current protection only.
Yes, it needs a fuse or MCB as well.
And an RCBO combines everything.
Exactly. RCD and MCB in one device.
Those are common in houses now.
Very common, especially in modern switchboards.
Makes fault finding easier too.
Yes, but for the exam, just remember the functions.
Okay,
Now, installation requirements. Where are RCDs required?
so on most final subcircuits in residential installations,
Correct. Can you name some?
socket outlets,
Yes.
lighting circuits,
Correct.
fixed wired appliances,
Yes. And what about locations?
damp locations,
Such as?
bathrooms, laundries, outdoor areas.
Correct. Why are these higher risk?
Because people are wet and body resistance is lower.
Exactly.
So RCD protection is essential there.
Now let's talk about testing. How do we confirm an RCD works correctly?
Using an RCD tester,
Correct. What tests are performed?
it must not trip at half rated current.
Yes.
It must trip within time at rated current.
Correct.
And it must trip within time at 5 times rated current.
Yes. And at which phase angles?
0 and 180 degrees.
Correct. If it fails any test?
It's electrically unsafe and must be replaced.
Exactly. Now let's finish with a summary.
RCDs protect people.
Yes.
They do not protect against overloads.
Correct.
They do not protect against short circuits.
Yes.
That's the job of fuses and MCBs.
Perfect. That's a solid understanding of part 2. Okay, Sarah, let's finish topic 13 with isolating transformers and transformer ratings.
Yep, this part always feels shorter, but I know it still matters.
It does. Let's start basic. What is an isolating transformer?
It's a transformer that changes voltage?
Not quite. Voltage change can happen, but that's not the key point here.
Oh, right, okay, it separates the supply.
Exactly. An isolating transformer has a primary winding and a secondary winding with no direct electrical connection.
So the windings aren't physically connected.
Correct. The only connection between them is magnetic.
Through the transformer core.
Yes, because of that, the secondary side is not connected to Earth.
We said it floats.
Yep, floating secondary. That's an important term.
And that floating part is what makes it safer.
Exactly. Now think about electric shock. What normally causes shock?
Completing a circuit through the body.
Correct. Now if someone touches one conductor on the secondary side of an isolating transformer, what happens?
Nothing happens?
Close. A circuit is not completed, so current does not flow through the body in the usual way.
So the shock risk is reduced.
Exactly. Reduced, not eliminated, but much lower.
Okay.
Now, here's an important exam rule. How many appliances should be supplied by an isolating transformer for maximum safety?
1 appliance.
Correct. Maximum safety is achieved with 1 appliance only.
What if there are 2 appliances?
That's where the risk increases.
Because you could touch 2 metal parts.
Exactly. 2 exposed conductive parts at different voltages can recreate a shock path.
Even though it's isolated.
Correct. So if more than 1 appliance is supplied, what must be done?
They need to be earthed?
Not quite. This is where students often get caught.
Oh, okay.
The exposed conductive parts must be bonded together.
Bonded together but not earthed.
Exactly. Bond together but do not connect to the installation earth.
If you connect them to earth, you lose the isolation.
Correct. That defeats the purpose of the isolating transformer.
So bonding only, no earth connection.
Yes, that wording is very examinable.
I'll remember that.
Now, where might isolating transformers be used?
In medical areas?
Yes,
Laboratories?
correct.
Maybe workshops with special equipment?
Exactly. Anywhere higher shock risk exists.
And they're often used with other protection methods.
Yes, isolating transformers don't replace other protection.
They work alongside things like RCDs or double insulation.
Correct. Now, let's move on to transformer ratings.
This is where kVA comes in.
Yes, very common exam question. Why are transformers rated in kVA and not kilowatt?
Because kilowatt depends on power factor?
Exactly. Good answer.
And transformers don't control power factor.
Correct. Power factor depends on the load connected to the transformer.
So the transformer still has to carry the same voltage and current.
Exactly, regardless of whether the load has good or poor power factor.
kVA is volts times amps.
Yes, that represents the total electrical loading on the transformer.
Kilowatt only shows useful power.
Correct. It does not show the full current flowing in the windings.
So using kilowatt would underestimate the transformer loading.
Exactly. That's why kVA is always used for transformer ratings.
That makes sense now.
Good. Let's do a quick summary to lock it in.
Isolating transformers separate primary and secondary windings.
Yes,
There's no direct electrical connection.
correct.
The secondary floats and is not connected to earth.
Yes,
One appliance gives maximum safety.
correct.
Multiple appliances require bonding but no earth connection.
Exactly.
Transformers are rated in kVA, not kilowatt.
Perfect. That's a solid understanding of part 3.
All right, that brings us to the end of topic 13.
Yep, that was a big one, but it feels clearer now.
Good, that's the idea. How are you feeling about the EWRB exam overall?
Still a bit nervous, to be honest, but listening through it like this helps.
That's normal. Just keep revising little bits often. Don't try to cram everything at once.
Yeah, I've been doing short sessions, usually in the evening.
That's a good approach. Even listening while relaxing helps reinforce things.
True, sometimes I just play it back while lying down.
That's perfect for theory. Repetition matters more than speed. By the way, how's the weather been for you lately?
Typical New Zealand weather. 4 seasons in one day.
Yeah, same here. Makes it easier to stay inside and study, though.
Exactly. Not much excuse when it's raining outside.
That's true. All right, thanks for spending the time working through this topic.
Yep, thanks for explaining it.
Take your time, keep practicing, and we'll move on to the next topic soon.
Sounds good.